Part of this week, the idea of part of this week is that you build something yourself, because in our mind it's the best way of actually learning stuff, right? So you learn something while you do it, and I think this is amazing. Now, just to give you some ideas in mind about my background here, so I've been sitting here, I think mostly not in this very room, but at ETIT, up the street from here, where I did my undergrad and master's. So at electronical engineering, my bachelor's, and then biomedical engineering. Then did my postdoc and PhD in Basel at BSSE. And then somehow I was going to Bitcoin meetups, and there was like this thing called blockchain around. And somehow just after the week that I defended my PhD, there was this first Ethereum developer conference. And I said, you know, what the hell, let's go there. Like, after you graduate, somehow nobody really cares what you do, so that's kind of a good excuse to do that. And it was there, like, that's actually where Andre and me really got together and said we need to do something here in this space and enable people to build something with it, that something struck me. And I realized that this is going to change a lot. Like, this technology is going to question a lot of paradigms that we're all used to, both the business people as well as the developers, right? So who here has some sort of development experience? Awesome, I love that. Okay, this will be fun. So that being said, for most of you guys that have some development experience, you're used to a certain way of thinking. Now, that's sometimes a problem. And that is sometimes a problem because you think in specific patterns. You think in patterns of client-server, master-slave, right? Web app. That's a way of thinking, and that is the very thinking that led to some of the most, let's call them interesting problems in the space. When I say interesting problems, I mean, for example, some issues in software code that led to around $500 million just going boom in a second when somebody calls the wrong function. And we have to challenge that, right? And what we're going to do now is to go through a very simple introduction. Recognizes the logo on my t-shirt? Anybody seen that before? A few? Okay. So this is the logo of Ethereum, which is a blockchain. And now there's many blockchains out there, right? And there's these private blockchains, and there's this Bitcoin blockchain. So let's just like not get into like what are all these different blockchains and why are they good and why are they bad. The first blockchain that we've all seen and that had an actual real-world application was Bitcoin. It's been around like since 2008, 9, 10, like depending how you count it. And this enabled us to basically have a financial system that is inclusive to anyone in the world that can transfer value. And this is pretty cool, right? So you have a means of sending money from here to the other end of the world, you know, and nobody can say no to that, and nobody can really stop you. This was pretty powerful. And then there has been some guy that was probably at that time younger than most of you here in the room that said, this is really cool, but what if we could do much more with this blockchain thing than just sending around money? What if we could use this system that enables us to send money from A to B to run computations that involve A and B, right? Because, I mean, what is really a financial transaction? What is a financial transaction really? If I transfer you money on some bank account, it really is a little script that says, let's say I send to you some money, like I send you, let's say, 10 Swiss francs. What this little script does is, if Sebastian has at least 10 francs on his account, then continue. Then minus 10 here, plus 10 there. That's the end, right? Now, if we can do that, why can't we do more? Why can't we, for example, say, Sebastian does send money into this lockup box here, and you can take it out of this box if on the 20th of February, the sun is shining in Zurich. And now there's people in the financial space that have kind of fancy terms for that, like weather futures and stuff like this, which again sounds very financial. But bottom line is, we have a little script that is running somewhere that is guaranteed to be executed, that cannot be shut off by anyone, that is accessible to everyone out there, and that enables that. And this idea of building these things, so these constructs, so put money in a box, if certain conditions are being met, you can take the money out again. This is what we today call a smart contract. And the first system that has put that into like large public use was the Ethereum blockchain. And that's the idea that Vitalik came up with. And that was about 4 years ago. And about 4 years ago, he wrote like this white paper, and people looked at it and said, you're fucking crazy. First of all, you're barely 18 years old, so what are you even talking about? It was a time when there were many blockchains, and they were all like well, it was either called altcoins from people mining it, or there was this other group, they called them shitcoins. And Ethereum was basically one of these shitcoins that came up and had a great idea, and basically wanted to make a lot of money, and then not deliver, just like all the others. However, things unfolded a little different, and of course, because there were delays, because that's just how software projects go, they did deliver. And this vision of a decentralized world computer, basically a virtual machine, did unfold, and we have it today, and that's what the Ethereum blockchain enables us to do. So on the Ethereum blockchain, we can write these smart contracts, which is basically a script that gets compiled into bytecode. And this bytecode is not just running on your machine somewhere. This bytecode is not just running on this laptop that I'm going to demonstrate it on. It's running in a global network of machines that are kind of globally distributed all around the globe. And we're going to play with this here now. So the first thing that we're going to need to write some smart contracts there is like a development language, because I said it compiles into bytecode, but typically we don't write bytecode, right? So in the Ethereum world, people developed their own smart contract language. And now you can debate whether that's a very good idea or not. However, they did that, and they based it off JavaScript. I can see some faces now that say, oh my God. And there's some truth to that, right? I mean, JavaScript is not exactly known for writing like really, really stringent and correctly, syntactically easy to, review financial contracts. But at the same time, we need something that is accessible to many people out there, and that makes our life a bit easier than some very, very, let's say, academic but correct smart contract constructs in other languages that we have seen. So this language is called Solidity, and the Solidity language is still undergoing heavy development. So if you look at this general ecosystem, 2.5 years ago, when this Ethereum Genesis block came out, I can tell you could not have really done anything with it. Like, the compilers were crap, the virtual machine was not really working except when you were running it on an LTS Ubuntu. And so it was really, really difficult. And why I tell you this is because if you start like, I don't know, some sort of niche of software development that you ultimately will need to specialize in, like, let's take Java, right? So you have around 200 years of software development to catch up on. So, and in the Ethereum world, I mean, that's 2.5 years since we started. That was ground zero. So don't expect very fancy toolings. Don't expect very developed libraries out there. It's pretty much, you're with your hands in the dark, and you're going to see what that means in a minute. Yeah. So I would like you to get your laptops out and start a browser, because we are going to work in a browser-based IDE, so a development environment that is accessible just through your browser. And generally, I recommend working in Chrome, but if you have other flavors, that might work out well. Tomorrow, we're going to use one plugin that will require you to have either Chrome or Firefox. So that's up to you what you use there. And it's beautiful to see that many people that are starting to hack. I hope that doesn't have kind of negative consequences on the IDE which we're using. We heard last time when we had buyouts 2 years ago that this was the largest usage spike they've ever seen, and I think that we had 50 people coding, right? So, all right, so I'm the first one typing, so I'm not going to be as badly affected as you are. So I'm going to remix.ethereum.org. And basically what this is a browser-based development environment. Am I online here? Well, barely. Could somebody connect me to a Wi-Fi here that... Public 5? Ja, wir nehmen einen Adapter für das one. Da brauchen wir einen Adapter für.
Dann habe ich hier einen Adapter. Also für Ethernet meine ich. Das nehmen.
Dann kann ich das auch hier. Lass mich hier versuchen.
Okay. Nein, ich möchte nicht. Okay.
Ja, lass hier den nehmen. Lass auf anderes bleiben.
Also. Wissen wir die?
Das ist meine. Dann stecken wir ihn hier über den Projektor.
Ja.
Kannst du mir kurz helfen? Kannst du mir kurz helfen mit den Einstellungen hier?
Das müsste eigentlich relativ gut auf Anhieb funktionieren. Ja.
Wow, nein.
Das Format passt nicht ganz. Du hast 16.9 hier, wenn du es umstellen kannst. Gut, super, super.
All right, sorry for these short technical hiccups. We're going to start coding now in the Remix environment. So as I mentioned, it's browser-based. And just another side note while we're getting started, one thing that is kind of very attractive to me in this whole blockchain space, and that's nothing new, but it's really being embraced, is that this ideology that kind of people bring along in the blockchain space. Everything is open source. If you don't code open source, you're a clown, right? Everything is kind of inclusive to people out there. And while not everything is very easy, you try to help each other, right? So there's this Stack Exchange, so Ethereum.Stack Exchange. So Stack Exchange is this general page where people can go and ask like IT-related questions. And there's one for Stack Exchange. So like help each other, okay? Help each other. When you try to see some issues, let's try to resolve it because this group is too big that I can go around and help everyone. So after we start Remix, I hope this works for everyone, we have this browser-based ID and it might contain some sample content that you can just delete. So what we're going to do now is we're going to write our first smart contract. And just from a notion of people that have experience in software development, you might be used to object-oriented software themes, right? Like classes. So whenever you see contract, think of class. Okay, a contract is just like a class in that it contains some methods and some properties. That's pretty much the equivalent. So the first thing that we're going to do now is in our remix, we're going to type contract hello world. Right? And open and close curly brackets. It has already autocomplete. And that's pretty much it. That's our first very simple and very useless smart contract. And the next thing that I'm going to do is I click on run. And for you, So up here in the Run tab, you should see in the environment already auto-selected JavaScript VM. So what this is, and this is actually pretty cool, behind the scenes, this is fully client-side. So you have an entire compiler as well as an IDE that runs on your machine now. So you can basically disconnect from the internet now and keep coding here. That's quite neat. There's also other IDEs which I will get into later. So for the ones that still had issues, so remix.ethereum.org, and you can just delete the sample contact on there. So first thing I'm going to do is here on the right side, so if you tap on the Run tab, you have this Create button here. And that's what this Create button does, is it creates an instance of our smart contract. Now, if you're used to some sort of software development already, then what we write on the left side is like a schema for a database. And what we have on the right side is an instance of this database. And this database has here an interesting thing. It says hello world at 0x692. And what this at 0x692 is, it's an address. And this address is where your smart contract can be found and interacted with. Everything on the Ethereum blockchain has an address. An address can basically, behind an address can be two things. Either you or a smart contract, right? And one thing that you please keep in mind is we don't discriminate, right? We don't discriminate smart contracts, and if you do, bad things happen. Many of the exploits that we have seen early on that led to hundreds of millions of dollars being lost were because people thought, again, that's what I mentioned initially, this old way of thinking. You have a person on the other side of you that's going to react upon you doing something. Now, that's not always correct. On the other side, you might have a smart contract that is programmed to exploit your little treasure trove that you were coding up there. Okay? So keep that in mind. We have these.
No, sorry.
I'll come back. So basically, everything in the Ethereum world is an address, and it can be either a person. We also call that an externally owned account, because you're in control of this thing, or it is a smart contract which executes some code. So I will not spend too much time on the low-level infrastructure because you can read that up and it's not really so helpful for you getting started here. I will jump right into how we can code and develop some primitives that are running behind the scenes as we go. So in our contract now, I mean, it's not really doing anything. It doesn't expose any functions or properties. We will basically put in a little property. It's of type string. So it's some text that it can hold, not sting, but string. And we call that a greeting. Yeah, and put a semicolon at the end of the line. It is quite explicit on that. Okay, so we have now some properties a property that we can store. So now we need a method to set it and to get it. So let's write our first function. That's called setGreeting. And this function, of course, gets one parameter, and this parameter is the new greeting to which we want to set it, right? So string new greeting. And after that, we need to basically tell it, and we want to be nice, also just because we found out if you're not nice, bad things can happen, that this method is public. Public means it is available to be called from anybody out there. And also here, a note of caution, if you just write something private, so this function is going to be public now, you could write it private. This does not mean that the stuff that you do there on this blockchain, which is currently a network of about 27,000 computers out there, is hidden, okay? Just because you make a function private doesn't mean it can be read, it's just a bit more cumbersome to read it. Okay, so this function is explicitly public, and the only thing it does is it sets greeting to new greeting. All right, and the only thing we need now is a getter. So this is our setter function, and the next thing that we need now is a getter. So I'll just write another function that's called getGreeting. This function obviously doesn't get any parameters. It is, again, public because we want to allow anybody and also other smart contracts, whoever is out there, to read our greeting. And now this function is a little different. Now, think about this. We have this blockchain, which fundamentally is a distributed database of 27,000 computers out there. Now, all these computers store a copy of the entire history of what has happened. If I want to write a variable, this variable is going to be written into storage of all these machines out there. If I want to read, I don't want to inform all these 27,000 machines that I want to read something from them, right? So that's why we mark this function here as view. So it's basically telling it that, okay, what you're doing here is a function that is just for reading, and it's not for writing any values. And this one here returns a value, and it returns a value of type string. And what we're going to do here is we return this greeting. Greeting. Good. Okay. Thank you. That's the thing that you don't see when you stand in a lot of people. So let's see what happens now. I'm going to delete, by the way, you can delete your old smart contracts that's running in our sandbox. So this is right now only on your machine, right? So you're not running something that writes to all these 27,000 computers, so don't worry. So I'll delete this instance here and create a new one. So what we see down here is we have now an interface that is wrapped for us just for testing of the smart contract. It makes it a bit easy for us to interface this function. You see one of them is a bit pinkish and one of them is kind of reddish. And the red means this is a function that is not a constant function, so it's not a view function, meaning this function changes a state which is going to be written to the blockchain. This pinkish bluish thing here is a function that's just doing a read. So it tells you already what you can do with this there. So what I'm going to do here is I'm saying hello buyouts, right? And if after I call this function, I click on get greeting, I can read back our value. And that is already our first hello world smart contract, right? So it's not that hard. Now, you might see that, okay, we have now this function and this works pretty well. And if you have any sort of idea, like you can really work with this just like with the database scheme where you read something back from it, you execute some logic. So this smart contract is pretty much like a stored procedure in database lingo, right? So stored procedure is something that's inside your database. It can operate on data and calculate something. Now, this is what we're really building here. So we have this schema of our smart contract, which we upload into the blockchain. At the same time, our schema also contains some stored procedures with which we can execute some code, such as this pretty useless return of a value that I have here. Now, one thing that will become apparent when you use this in a larger setting is, as I said, this is now accessible to anybody out there. Okay? So anybody out there can change the values that you have in here, which might or might not, depending on the use case, what you're after. So in traditional software development, we have a huge infrastructure around like role management, user management, access management, right? So people need to build firewalls and encryption systems and kind of have admins that handle all that stuff. And earlier or later, it always breaks, right? So earlier or later, like somebody can penetrate the castle walls that you're building up there to protect what you have inside. Now what we're doing here is that we have everything, all these function calls, all the function calls that go out here to this distributed network are actually transactions. And they're transactions just like Bitcoin transactions with which I can send money from me to you. And these transactions are secured, without getting into too much detail, they're secured by a private key. So it's a secret which you use to sign it. So we put a signature under it. So every single account has a private key that signs a message. And this is a way of how we can be sure that nothing can be tampered with inside a smart contract. Let's give an example. For example, what I'm going to say is the person that deployed that smart contract and puts it on a blockchain is the owner of it. And only I, as the owner who deployed this thing, can change values. Like, that's a very simple pattern. And if we code that into a smart contract. We don't need to bother with any sort of user management, role management, security, firewalls, all that crap, right? So all that stuff, which is like billion-dollar infrastructure, we don't need just because we have private key cryptography, which on transaction level ensures that nothing has been tampered with. Unless, of course, your private key has been messed with, right? So that's important if you set up like a wallet and you transfer Ether and so on. Don't lose private keys, because any sort of assets, just like Bitcoin or Ether or some sort of tokens, but also functionality, like for example, the allowance that you can change this greeting will be gone. Now, just to make it a bit less abstract, let's give an example. So what the people that did some object-oriented programming, what they're used to as a constructor. A constructor is a special function that is called whenever you create this object or an instance of this object. So, and of course, we have the very same thing here in Solidity. And a constructor works like this. It's just a normal function that has the exact same name as your contract. So I will call it function hello world. And what I'm doing in here is I set another property. So I have to define the owner, and the owner is of type address. Now address, you can see, is something that is not common in JavaScript, right? So this is one feature that goes beyond the traditional JavaScript stack and provides us some means of interfacing Ethereum contracts. So my function hello world, which is the constructor, doesn't take any parameters, and it just sets the owner. Now, to whom does it set it? And here we start seeing something that in my mind is really, really interesting. So we need to set it now, at this instance, we need to set it to whoever just deployed me. Okay, so I, the smart contract, am sitting on a blockchain, and I need a means of ensuring that the person that just deployed me is set correctly and cannot be messed with. And also here, Solidity provides us a primitive that's this message object, and it's called msg.sender. Now, msg.sender is part of this transaction. So whenever you would deploy this contract, so basically here it's kind of made in a very, very clicky fashion for you. You can just click this button and it's magically there. Now, what is happening behind the scenes? You actually have first of all compiled this JavaScript-ish looking Solidity contract into bytecode. Yeah? So that's like a first relatively big topic. So this thing is now existing actually in bytecode. And if you click on, where is it? If you click on compile and details, what you see is this bytecode here. So this is what happens behind the scenes in this remix. So this bytecode is running on the Ethereum virtual machine. Now, why exactly is this Ethereum virtual machine running, right? A virtual machine just means it's a piece of software that's running on some computer. Now this particular virtual machine is running on all these 27,000 computers that I mentioned initially are connected to this Ethereum blockchain. So what happens is, after I click this button, if it was a real blockchain now, first of all, it would have been compiled, sent out the compiled bytecode out to the blockchain. Then eventually it gets incorporated in a block, means just it's written into that blockchain now and nobody can change it anymore. And the transaction that I was just sending is additionally signed by my private key, meaning nobody of you can impersonate me, right? So this message sender object is associated to the account that I use up here. And Remix basically gives us 5 accounts that are pre-populated with some money. So currently each of them has around $80,000 on it. Unfortunately, it's not real money. So let's go ahead and let's now use this owner object. So far I was just setting it, okay? So let's say the set greeting can only be called by the owner. So what I'm going to build in is a require statement. Require, and now I'm just checking that the one who's calling me now is indeed the owner. And I just write msg.sender, same as above, equal to owner. So with this one, I ensure the caller is really the owner. If somebody else tries to call it, the execution is aborted at that step and the next line doesn't happen. By the way, for the ones that are a bit more into software development, what actually happens behind the scenes is we have an entire state rollback, okay? So it could be that you had another function or indeed even another smart contract calling our function here. This other smart contract could have done some state changes, for example, like put some, I don't know, some message somewhere, set some variable to something, call another function. Now, down the line, we're calling this function here, and this require statement here blows up. What happens is an entire state reversal, so everything that happened until that time is being reversed. So you don't have to worry about kind of like how that I'm in a messy state or something like this. And this is actually pretty profound, and this is actually pretty important. Because what it means is that you really have atomic transactions, and you have atomic operations. Now, and this is just a short anecdote, I try to keep it short. There's been a very notable non-atomic transaction in the financial space. There was a fantastic German bank. They're good with engineering, but maybe not so good with banking. And there's been another bank that was in the US. This bank in the US had some not so good times. It was called Lehman Brothers. Now, this bank in the US had some products that they offered, right? So some financial swap agreements. And what this German bank did was they had a totally normal business operation. They said, you know, we sent like 200 million there and then some agreement kicks in. What this German bank was not informed about was that this other bank in the US was just in bankruptcy and insolvent. So what happened is $200 million going this way, nothing going back, right? This is an example of a transaction which is not atomic, means it either happens completely or doesn't happen at all, and it's also not deterministic. Deterministic means you have no clue, or not deterministic means you have no clue what's going to happen on the other side. Here, you can rely on this, and straight reversal basically ensures that. End of the side story. Okay, we have this require statement, and let's do a little demonstration. I again kill my old smart contract, create a new one, and I'm setting a greeting to hello biots. I can read the greeting, everything is fine as it was before. Now, if I try to select a different account up here, I select now the second account, and I'm writing hello ETH, and I'm calling the get greeting, nothing changed, right? For the ones of you that were a bit observant and see what's happening on the screen here, we see this console output down here. So let's look into this console output and see what happens. Another side story starting. So what happens is we have here in the details view, you already see that it says transaction to hello world set greeting errored, VM error revert. So what the hell does this mean? It means the require up here blew up. Sorry, we don't really have beautiful means of informing about error. We don't have different types of exceptions. You will just have to live with this for now. Also, just in case you're wondering, debugging that, yeah, it's a bit of an issue. There's some debugger in here embedded in Remix, but I'm not going to show you because once you have problems that you actually need a debugger for, it's not going to help you. So, yeah, that's what I meant initially with you're a bit out in the dark on your own. So, what we see here, let's look into this a bit more in detail, what has been happening here. So if I open this transaction, we have all these details, and I just wanted to walk with you through what this is now and take a little bit a look behind the scenes of what is actually going on in this Ethereum blockchain behind the scenes. So first of all, we have a transaction that goes somewhere, and it goes to 0x0897. What is that? What is 0x08 something? Anybody has a clue? Yeah?
Probably the address of the smart contract.
Yes, the gentleman here says it's the address of the smart contract. And exactly, that's right. So if I look here, it goes to 0x089, and it says hello world is at 0x089. Yes, so I send a transaction to the smart contract, right? It's coming from 0x147, that's me, right? That's the account that I selected up here, 0x147. Let's skip the annoying stuff here. We'll get to that later. And we see this input. Now, this input looks really weird. It's like this long thing. There's some data here and there's some data here, right? And in between, there's a lot of nothing. So what is this? We call it a function. And this is something that sometimes you have to be aware of because it's kind of abstracted away in a way for you that you don't see it. But under the hood, what you do is when you call a function in Solidity, you send a transaction. We send a transaction to the smart contract. In a transaction, you have to tell it actually, hey, which function am I actually calling, A? And B, you have to pass function parameters. Now, let's just digest this thing here. So this A41368 and so on, the first 4 bytes is a so-called function identifier. And it basically tells the smart contract which function am I calling. Microside note, it's the SHA-3 hash of the function header, right? So it's unique, relatively unique. Now, what we else have in here, it's basically a string that is kind of packed in a format that the EVM understands. So the first argument with this 2 in the end tells it how long it is in words. The EVM has a 32-byte word length, and that's just because it fits really well with some of the cryptographic primitives, like 256 bits that we have for addresses, for example. And this is what we pass it, right? So my hello ETH in ASCII representation is this. So this is what we do in our function call. The next thing that we see in here is we have a transaction cost in gas. And this is something that to people is usually confusing in this Ethereum space. I said initially, we have 27,000 computers all around the planet that get together and kind of work on this Ethereum blockchain. Now, if I transmit data that is hello ETH, which is pretty useless to these 27,000 computers probably, why would they do that? Like, why would anybody bother about me wanting to do such a thing? Some of these people that run this network, that actually secure the network, have to earn something for it. So there's some dedicated machines running behind the scenes that are actually working on enforcing the security and the global state consensus, as it's called, so the state of our database. These people are called miners. And one of the first and largest firms in Switzerland that was running these mining operations was Andre, so talk to Andre about if you want to learn something about mining. Now, what is happening here is you as the person that calls it, that wants to set a greeting, you have to pay these people, because otherwise why would they bother to include your transaction? Okay, and you pay to them, obviously, in Ether, in the native currency in this blockchain. Okay, this next part gets a little bit complicated, but we will get back to afterwards. Now, how do you pay? You pay in a concept called gas. Gas is a bit like gas that you tank in your car. If you're in a car and drive from Zurich to Basel, it might cost you, for example, I don't know, depending on your car, like 2 liters, yeah? So you need to have at least 2 liters of gas in your car, otherwise you're not going to make it to Basel. So if you have too little gas, your car is going to die halfway, and you're just going to sit there. Same thing with these smart contract function calls. If I send it too little gas, it's just going to die and not really do anything. Let's do an example. So I'm going back to the account that has access to the function, and I'm calling this function. Scrolling down here, and this worked really well, right? I can set it to any sort of values, and this works always pretty great. If we look into these transactions, it actually cost us around 33,000 gas. Yeah, so it costs like 33,000, I don't know, liters if you want to take this equivalent to call this function. Now, up here, you see this gas limit. This is what I put in my tank before I take off. So let's say in my tank, I only have 20,000 gas. And I call this function again. And what we see here, okay, it fails in a not very beautiful way, but what we see here is that this transaction does not make it. Why does this transaction not make it? Because your car basically doesn't have enough gas to make it to Basel. Yeah? Okay, this is the concept of gas. Now, how do you pay for this? How do you pay for this? You pay for it in Ether. So there's a constant bidding market going on where people have to see, hey, what's the backlog of transactions that all want to make it in, right? It's not just us, it's also thousands and tens and hundreds of thousands of other people that want to use that blockchain. There's a constant backlog of transactions. And if you're a miner that makes money on this network, which transactions would you include? Like, which transactions would you take up into the blockchain? I guess, say again? Yeah, exactly. The ones that benefit you most, right? So this is some sort of a free market model for computational execution of functions, which is pretty cool, actually. So you can just say, hey, I want to run this function which is really complex, yeah? So you have to pay more. You can have a function which takes a lot of data. By the way, this is the two ingredients that you pay for: sending data, computational execution. These two steps is what you pay for. And yeah, and then you just set a gas price and you say, hey, it's like super important. I really need to get this thing out. So you pay a lot. You have a higher gas price. If you say, hey, I don't really care if this thing is pending for an hour or two, then you just make it cheaper. This is just a market for computation. Okay, end of the side story. Now, what we've seen here is bottom line, just set your gas amount high enough. Yes?
Two questions. One, my price was much higher than the one who get quoted.
Yeah.
So why is that? And the second one is, if there's something pending and I want to recall it because I'm thinking, okay, then I rather think about what I'm doing, how can I do it?
Yeah, so second question first, because it's a very interesting one. So let's say, and this was an actual case, you send out a transaction, you said, oh, I didn't mean it that way, right? Shit. So first of all, you cannot. Tough luck, right? So oops, I put like 2 zeros too much and I sent you, I don't know, 100,000 instead of like $1,000, right? Tough luck. Please send it back to me. Yeah, that's what you can do. Now, the other part that is actually interesting, it's pending for a long time. And it's been like one of these, like people looking, what is the killer application of blockchain? I think we answered that, it's tokens, we'll get to that later. But people have come up with like funny concepts of games. So there has been a very, very popular game called CryptoKitties. So in CryptoKitties, like you have this little kitty and it grows up and so on, and you can then make little CryptoKitties with it, you can also sell it and so on. So, and this game was really popular. Now what happened there is some people were playing with their CryptoKitty and this thing didn't get mined because people were too cheap in the gas price. Now what you can do is you can rebroadcast the same transaction with a higher gas price. So you can't take it back, but you can broadcast the same transaction again with a higher gas price and hope that it makes it sooner. But then, of course, so this just to answer the second part of this question, of course, like you can't do that arbitrarily. There's a thing that prevents kind of replay protection. It's called a nonce, and every single transaction increases this nonce. So you would have to rebroadcast it with the same nonce. Yes?
Also, two questions. First of all, does that mean that if I am calling a couple of functions in my function, that because they're transaction, there's no actual guarantee in which order they're going to be executed? And the second question is, if I set a gas limit, is that just the maximum and my transaction will go through at market price? Or am I setting like a limit price, like this is my offer?
Yeah. So also second part of the question first. So there's two different things. I think we actually don't see them both here in this output. You have a gas price and you have a gas limit. The gas price means how many ether, usually subunits of an ether, because otherwise it would be crazy expensive, are you willing to pay per gas? The equivalent is 1 liter of gasoline costs, I don't know, 1 franc 50. So this is what you set, and this is what the miners determine what to include first. The other thing, and that's where the second part of your question is, you set this gas limit, which you are maximally willing to pay for the execution of the code. Typically, you know that ahead of time, because it depends on A, the amount of data, and you know that, and B, the computational complexity. So you usually know how much it is. And you set this, it's basically a cap. Whatever has not been used is been sent back to you. So even if I set like a crazy high value here, even if I set something very high, you will get that back. So you see in this example here, so this gas, it's sometimes also called gas limit, I think it's around 3 million. Yeah, it's 3 million, but it actually just cost us 33,000 gas. So the rest is basically returned back to us. So the total that you have to pay for is the transaction cost in gas times the gas price. And if you have multiple functions, you will pay for the whole thing. So if you call a function on a smart contract that calls a bunch of others, you pay for the total. Also, one thing, because it always comes up, a smart contract never pays for its own gas. You always pay. So a smart contract only can be triggered from the outside, and you, as the person, externally owned account that triggers that, pays for the entire cascade of function calls that come out of it. Okay?
Can I also rebroadcast transactions of others with a higher gas price, and I will pay kind of to speed their transaction up?
That's a very cool question also. Yeah, that's a very, very cool question also. So can I rebroadcast in other person's transaction? So first of all, no. Why not? Because a transaction is signed. A transaction that you send, I cannot rebroadcast because I could not sign it again. So everything, all the fields that you see here, including the gas price, are being signed by your private key. I don't have that, hence I can't broadcast it. But your actual question is, can I actually pay for other people transaction fees? And there's like people are looking into that. It's a discussion actually ongoing right now. Yes, in a way, but it's complicated because basically you can broadcast it off blockchain. Say, hey, I give you, I don't know, I pay you for dinner if you broadcast this transaction. Now you can do that in a trustful manner that I sent you a transaction, and part of this transaction includes an incentivization for you. Specific example, and it's actually one of the first use cases of Ethereum that I found really cool, is the so-called Ethereum alarm clock. What the Ethereum alarm clock said is you can schedule a call that has to happen in half a year from now. There's nothing like this embedded in Solidity. There's no set timeout or something like this, because you would have to have a timeout loop running on 27,000 computers, which is stupid. Now, what this thing did was you can call this function in a year from now, plus minus an hour, let's say, to give you some leeway. If you do so, you will receive, let's say, I don't know, 0.1 Ether for it. Yeah, so these sort of things are possible, but it's a lot more complicated than what you can do with vanilla Solidity.
So the cost of the transaction is calculated by like the, no, I start differently. So the gas is transformed into an ether price, right? By the gas.
It's a multiplication.
Yeah, okay. Can you set like the gas limit higher than what you have in ether, if you like?
No. So basically, this is, I don't want to get political, but basically what we have here is Vollgeld, okay? So what does Vollgeld actually mean? It's like, there was a bit of debate here in Switzerland about this. It means there's no negative numbers, right? So in Ethereum, you have for your balance, there's no credit system embedded. So, which answers your question, you cannot set a higher gas price than gas price times the gas limit, what you have on your balance.
Because this is checked.
Yes, and now interestingly, how is this checked? This is checked, we have this relay network between all the nodes, and my node, or that's by default how they're configured, they would not broadcast a message if it's not matching this criterion. Specifically, why? Because it's DDoS attack vector, right? So if I can broadcast like all these stupid hello ETH transactions, I don't have any money on my account, I broadcast it, all your node broadcast it to each other, you can DDoS the entire network and it's end of the story. That's why by default nodes have kind of a minimum gas price that they accept in the first place, so you can also not say, hey, gas price 0. So nodes would simply not broadcast that.
Right now, it's like that if I want to make a transaction, I'm depending on the miner companies. But is it possible to turn it around? Like if I say I make an auction, like the Hellenic auction, it's like I go for a price up and then say,
Yep.
I want to make my transaction in the next 15 seconds, and I give you this offer. Like first, I say my limit is 100, and then it's 200, and the first mining company that springs in
gets it. Yeah. Yeah, that's also a really cool approach. So what he's suggesting is basically a reverse Dutch auction on the transactions. So meaning if you include it like in a block, the next seconds prices act. If you don't and put it a bit later, then it's a bit lower. Natively in the protocol, no, you can't. And the reason why is because you just set a fixed gas price. Yes, you can rebroadcast, as I said before, but hey, you know, if you do that and I'm the miner, well, which one am I going to include? Well, of course, the one that you broadcasted first that has a valid signature. So the only thing that is being checked is basically the price. But if I think about it, you could implement that on smart contract level. So on smart contract level, you could say, hey, if, again, like similar to this Ethereum alarm clock, if you do include this thing within the first, like, you know, I don't know, 14 seconds, you do get amount X. Now, who has the decision power to do so? The miner. And this, again, we're getting into very high-level questions now, and I would like to get back to the code, but it's actually fascinating. So one big problem that you have in miners is so-called front-running attacks. What does that mean? It's a really nasty thing that people don't talk about. It's if you have this transaction, this one here, which is not particularly interesting, but it contains a message that is important. For example, I want to participate in a crowd sale, right? I have a financial interest in getting this damn thing before you. If I'm a miner, I have the decision-making power what I do include in a block and what not. I don't have to go by the rule that, you know, I only include like the top paying transactions. I can say, you know, only the guys that pay me something. So like a so-called bribery attack, right? But especially with regards to kind of token sales, we do have this actual risk of front running by miners that say, hey, you know what? So there's something to be sold on blockchain, which is limited. It's a scarce resource. I can actually buy out this entire thing ahead of anybody else because I have locally, and at that point in time, I have the decision-making power on it. Yeah, so we're getting into critical things there, and not all of them have beautiful solutions as of yet. I would like to let's answer some questions in the second session, right? I would like to get into a few more details of Solidity that we play with today. So I would like to specifically actually show you a line of code that made me quit my job. So what we did here now is that we have a means of sending a transaction, and we have a means of ensuring that only a specific party can access something. Now, blockchains are also about money, right? So we can pay for stuff. So for example, what we can build, so Ethereum is a virtual machine. It's a computer. We've seen that now, right? We have functions and stuff. Bitcoin is not a virtual machine. Bitcoin is a ledger. What does a ledger mean? It's basically a book where you say, hey, this person paid me this much, this person paid me that much. What we can build on top of Ethereum in a smart contract is basically a ledger. So we have the virtual machine. On top of that virtual machine, we implement a ledger, right? So you can basically build that, and people today, like, it's a fancy word, you call it a token, right? It basically just means, hey, you have amount X, I have amount Y, and I can send my amount to you. That's all there is to it. Now, let's put something like this into here, but let's start with the native currency that we have at hand here, which is called Ether. Let's say, for example, we change the set greeting such that, okay, only the owner can send it. Like, let's basically remove that. So I'll comment that out because that's kind of centralization, right? And let's make a free market version of this. Let's say you can put a message to the smart contract if you pay for it. Okay? Now, let's put this in here. First of all, the first thing that we have to do, we have to tell it, hey, this thing has to be able to accept money. Why we did this? Because why has this been introduced? Because a ton of smart contracts early on have been deployed, and people randomly and stupidly sent money to them. And what we actually have then is a financial black hole. Okay? This is, by the way, fascinating. You can implement a financial black hole. You can send money to a smart contract, and I will show you one now. This is a financial black hole. Okay, what's going on? I made this function payable, it accepts money, and there's no way to get this money ever out of this system again. In total, in Ethereum, there's like many hundreds of $1 million in such financial black holes. Okay? That's the reason why people said, hey, this Solidity language is actually stupid, and let's actually introduce this payable modifier. This thing is called a modifier. And what it does is only functions that are explicitly marked as payable can accept payments, because usually if you as a developer are thoughtful enough to implement this thing, you do think about a means of actually getting rid of that money down the line. One question.
Couldn't you redeploy the smart contract?
Yeah, sure. But what do you do if there's a smart contract like this one here that contains $500 million? You're screwed. Yeah, and currently people are screwed. So no, there's no way. Like, there's no way. If this money is out there, if we have this kind of situation where money goes in but nothing comes out, end of line, that's it. So let's actually make the following. Actually, financial black hole is not always as stupid as it sounds. What it does is it is a means to limit the utilization of our message board without anybody profiting from it. And that's actually crazy. That's actually crazy. We have a means of somebody paying for a limited good without a central party benefiting from it. But let's make something else. Let's basically say, first of all, we need to now say, okay, that this person needs to pay at least 1 Ether. 1 Ether is currently around 800 to 900 francs, so it's quite expensive message board. So we only say require msg.value, so that's the amount that we send along. The amount that we send along, by the way, units, this is not going to be in Ether because, and this is going to be hard for a lot of you, the Ethereum virtual machine does not support floating point numbers. We only have integers and unsigned integers. Yeah, I know, it's a bit limiting. So what we do, though, is we basically use everything in unsigned ints, which is not such a big problem because they're 256 bits, so it's like big enough. And basically then interpret it on a user interface as some small number. So you divide it, for example, by 10 to the 18. That's a typical way how to handle it. So you can write, this is bigger than 1 Ether. By the way, Ether is a keyword, and it's just transferred into 10 to the 18. This is inherently working in Wei. So just like 1 Swiss franc is broken down into 100 Rappen, 1 Ether is broken down to 10 to the power of 18 Wei. Yeah? So this is what's happening here. Now let's actually try this out. So I kill this thing again. Whoops. Yeah, I don't know. Sometimes you need, like it's in Windows times where you need to Control-Alt-Delete your thing. So you refresh your browser. Oh. I will get to that only tomorrow. Okay, so reboot complete. I basically just refreshed the page. Sometimes if that happens, just refresh the page because this virtual machine, right? It's a bit weird. It's a virtualized JavaScript VM is then rebooted basically and runs again. Okay, so I will set a greeting here, and if I try again, hello world, and just set it in here, it just fails. Why did it fail? Well, because I didn't pay for it, right? So let's pay for it. I said bigger than 1 Ether, so I need to pay at least 1.1, and you see these subunits here, and I will send Ether. I'll try it again, and now you do see that this thing did go through. And with these very, very, very few lines of code, you can do super crazy stuff. I mean, with this, you can basically also do kind of bidding games. And it's very few lines of code. You can, for example, say, and there's some auction models that work that way. We have this auction where people bid, and you have skin in the game, so you have something that is in there, that is held in escrow by our smart contract. Then somebody outbids you. But you only get back by what the second most highest bidder was bidding, which basically prevents situations where you have just one party that bids a crazy amount of money and just to be for sure outbidding everybody else, and everybody else saying, hey, this doesn't make sense. You disincentivize such behavior with such auctions. Yeah? So this is something that we can write in very few lines of code. Okay, so what we have seen here, just to summarize what we did in this first Solidity session, is we have seen a smart contract. We have seen these message objects. We have seen how everything is secured by a key and we pay in gas. Things cannot be impersonated just because every transaction function call is signed. And therefore, I know who was the caller here. And we've ultimately also seen how we do a payment. And just to make it complete, let's facilitate a payout eventually. So what I'm going to do is collect money. And this is a function that is only accessible to the owner of our smart contract, right? So, and this is also important. Like smart contracts don't mean that we're kind of in this we're not only in this anarchy world where people don't make money. Yes, you can make money, right? You can build business models on top of smart contracts. So this message board allows me to collect money. So first, let's make sure it's only me. And, oh, this was, of course, wrong. So the second brackets here were, of course, wrong. So I require that it's me. And the second one is I want to transfer this money over to me. And what I will do is owner is an object of type address. Every address object has a transfer function. It's not a transfer function of what you learned at ETIT. It's just transfer of value. So transfer is just transferring money around. And now what we want to do is give me all, right? Now, how do we know how much money we have? You could either track this balance manually. So basically up here, you could increase a counter. I'm not going to implement, but I'm going to sketch it. So you would just say total equals total plus MSG value, right? So you could just basically track this manually. Turns out you don't actually need that. You don't actually need that because every address also has a thing that's called balance and gets the amount of ether that is on the balance of that object. Yeah. Second piece of information that's not new for most object-oriented people that programmed before. We have a this object. And for example, in C++, you have like a this pointer, which points to an instance of this class. Same fashion here, the this object is pointing, which is in blockchain space an address of the current instance. So what is this? This is just an address of the current instance of our smart contract. And then I can just write this.balance. And this means that the owner, and this is sometimes a bit misleading when you read it. It doesn't mean that please owner transfer. It means to the owner, we transfer the entire balance of the current smart contract. So let's check this last example before we go for lunch. I will kill this one and create a new instance. I will set the greeting to hello world. I will send 1.1 ether. I will do that again. Just to make a point, I will send it from a different account. Whoops. It just erased the balance here, so you have to enter it always again. So from this one, I send it again. This worked. So in the dropdown, you already see that we have some money that has been subtracted from the first two accounts. That's what I just paid for. And this money is now residing inside the smart contract, right? So how do I know that? Well, let's try. I'm basically going back to my first account and collecting the money. And going back here and see that indeed I did receive the payout and the money is coming back to me as the owner. Now, this is very, very few lines of code. And what I want to highlight here is that we have built a financial application. It doesn't make any sense, arguably. It's your job to come up with something that makes some sense. That has a transfer of value that works natively. We have kind of a management of different parties like owner and everybody else, so a very simple role model. And we have basically the entire security layer being taken care of, and all of that in basically 20 lines of JavaScript-ish stuff. This is why I think these smart contracts are really, really powerful and can really change many things that we're used to. And you can twist it for many applications, and we're going into a bit more details of how Solidity works in a second session after lunch. Thank you, and see you again after lunch.
So, 1 second, please, everybody, before you run away. Thank you very much, Sebastian, for the first part of your introduction. As you said correctly, we're having lunchtime now until